Hi, welcome back to the next video in the IB Math AA Higher Level series. Today, we'll be looking at the entirety of complex numbers. So complex numbers are basically just a set of numbers, just like any other set. For example, there's real numbers, there's natural numbers, so things like that, right? That you probably remember from either the first unit in Math AA Higher Level or from your previous education. So complex numbers are just another set of numbers. So just an interesting fact, as you can see, real numbers are an element of complex numbers. So every single real number you can think of is actually a complex number with a coefficient of 0 in front of the I. We'll look at what that means in a little bit. So a complex number is basically just a number with two parts, a real part and an imaginary part. So an imaginary part is basically a multiple of the square root of -1. So this I right here is the square root of -1. And so bi is just b times the square root of -1. So that just means any scalar multiple of I. And the real part is just any random number. So for instance, if I said 3 plus 2i, that just means the real part is 3, and the coefficient of I is 2, so the imaginary part is 2. So that's quite simple. In order to add complex numbers or subtract them, you just add the real part with the real part and the imaginary part with the imaginary part. So as it's written here, if you have a plus bi plus m plus ni, then you just do a plus m and then a plus in the middle of and then b plus n times I, because this is basically the same as bi plus ni, and then you factor out the I. So that's pretty much how you add and subtract complex numbers. Now to multiply, you could do a times m plus a times ni plus b times bi times m plus bi times ni, but this gets quite complicated, especially because I squared is actually -1, so you're going to have to keep changing signs and keeping track of that, so that can get quite complicated quite easily. So we'll look at how to multiply them in a little bit. First, though, you have to understand what polar form is. Polar form is just a different way of representing complex numbers, but instead of representing them as a scalar plus another scalar, so here say 2 plus 3i, we now represent them as a magnitude, so magnitude means a length, just like a vector. So like this thing right here is r, and the theta from the horizontal positive x-axis. So theta is always measured from this part of the coordinate axis here, not from here, not from here, not from here, always from here. So basically, from what you can see here, we use Pythagoras' theorem in order to represent complex numbers in polar form. So r is actually just the real part square plus the imaginary part square, and square rooted. So this is a right triangle formed here, so it's just square root of x squared plus y squared, and that's the length of the complex number. So this is basically just a vector, and this is the modulus of the vector. And then this theta here is what we're trying to solve for. So this theta is actually tan inverse of y over x. So this is something you might need a calculator to find, but usually if it's on a paper 1 question, they'll make the angles nice and easy, so you can use the unit circle to find it. So once you compute tan inverse of y over x, you've represented your thing in polar form. I'll bring up an example a little bit later on towards the end of the video so that you know how to do it. Now that we know about polar form, let's look at complex multiplication and division. So complex multiplication is now much easier with polar form. So if you want to multiply two complex numbers, say we call them z1 and z2, all you have to do is multiply their magnitudes, so r1 times r2, where this is r, this length right here, and then you add their angles. So you can write it as cos theta 1 plus theta 2 plus I sine theta 1 plus theta 2, where theta is here. So if this is the first one and then the second one, say we have something pointing up this way, that would be theta 2 with r2. So we just multiply their lengths together and then write cos plus I sine of the sum of their angles. For division, it's the exact opposite. We just divide the lengths and subtract the angles. So that's really easy now. Now let's look at exponentiating stuff. So if we want to raise something to a power of something, then we usually just multiply it by itself. But with complex numbers, as we saw earlier back here, if we try to multiplying them literally like this, it gets quite tricky. So we can't really do that here. So basically there's something called De Moivre's theorem, where if you have a complex number, r cis theta, where cis is just shorthand for cos theta plus I sine theta, this is identical to exponentiating only the power, so r to the n, and then multiplying that by cis of n times theta. Now, this should be quite obvious to you. This is just n additions of theta 1 plus theta 2, where theta 1 is identical to theta 2. So it's just adding theta 1 to itself n times. That's what a power means. So that's pretty much all we have to do in order to multiply or exponentiate them using De Moivre's theorem. But there's another way, exponential complex numbers. So Euler basically said that e to the I phi, or any angle here, e to the ix, e to the I theta, it doesn't matter, is equal to cos theta plus I sine theta. And so what that means is that a complex number represented in polar form can just be represented in exponential form by moving the angle up here and multiplying with an r. So what I haven't written here is that if this were r and then brackets cos theta plus I sine theta, then it would just be r e to the I theta. And because of that, there's a very special identity called Euler's identity, and this shows us that e to the I pi plus 1 is equal to 0. And this is probably something you should memorize, because now you know that at the angle pi, e to the I pi is equal to -1 if we just bring the 1 over to the other side. So this gives us another way of exponentiating complex numbers. So if I wanted to just do, find the cos theta plus I sine theta and square that whole thing, all I'd have to do is write it as e to the I theta and square that, which is much easier to find because now I just have to write that as e to the 2I theta, because it's the same as e squared times e to the I theta, which is quite easy for us to find. So now, oh sorry, I phrased that badly. It's just the same as multiplying the exponent up here by 2 is what I meant to say, but that came out wrong. So yeah, that's pretty much all we have to do. If we want to exponentiate something now, we just have to put that exponent up here next to I, and we've basically done it. So yeah, that's actually the entirety of the complex numbers that you need to know for the syllabus. So now let's just try a past exam question. So the question says, consider the complex number z1 equals square root of 3 minus 3i. Express z1 in the form r e to the I theta, where r is greater than 0 and theta is between -pi and pi. So I'll give you a moment to try this and then I'll walk you through the solutions. Alright, so the solutions are like this. So first you need to find r. Now what is r? R is the square root of root 3 square plus 3 square. Now we know 3 square is 9. Root 3 square is 3. So 9 plus 3 is 12. So r is root 12. So how do we get that? We just use Pythagoras theorem. Next, we need to find tan theta, right? So tan theta is opposite over adjacent. Now, if we go back to this diagram here, the coefficient of the imaginary is opposite and the coefficient of real is adjacent. So what we need to do here is equate this to opposite over adjacent. Now we see here that -3 is opposite because it's the coefficient of I. So we have -3 divided by square root 3 is our tan theta. And so if we calculate that using our calculator or just doing it using special angles, we see that theta is actually equal to -pi/3. Now that we have our r and our theta, all we need to do is write it into the form e to the I theta. So basically we need to put our r here next to the e. So here we put square root 12 e to the I times negative pi by 3, which, writing that like this, gets you the 3 marks. So yeah, that's pretty much the entirety of complex numbers. I hope you found this video helpful, and yeah, let me know if you have any questions down in the comments below. Thanks for watching.